lessons over how to graph ratio and rate tables. So let's go back to our previous lesson of do now. Let's see if you really have a firm understanding of how to complete a ratio or rate table. Jack bought 4 packs of hamburger that are on sale and paid $16 for it. Use a ratio table to determine how much additional he will pay to buy 3 more packs of hamburger at the same store. So, number of packs. Oh, it's so nice. I even labeled the units for you. 4 packs. It costs 16 bucks. But I want to know how much you will pay for 3 packs. Use the ratio table to determine how much additional will pay to buy 3 more packs. Ooh, I almost got that wrong right there. It's 7. So how much will he pay for additional 3 more packs? To 7. So let's build it up. Can I build this up? No, because I don't know what 4 goes into 7. So let's break it down and then build it back up. So scale it down, scale it up. So if I'm going to scale this down, I would divide both numbers by 4. I get 1. So 1 pack costs $4. So each pack costs 4 bucks or $4 a pack. So if I wanted to scale it up or build it up, I multiply by 7. 7 packs cost $28. So use a table to determine how much additional he will pay to buy 3 more packs. So if he wants to buy 3 more packs, 7 packs, pay $28 for it. So additional thing is he pays $12 more to get this. Alright, so how do you graph a ratio table? Which number in this order pair is the x-coordinate? Which number in this order pair is the y-coordinate? So 4 is the x-coordinate, 5 is the y-coordinate. So let's label this so we know that in a order pair, x comes before y. You can express information in a table as a set of order pairs. To see patterns, graph the order pairs on the coordinate plane. So let's look at a real-world question where you'll see where you need to graph this. The table shows Gloria earnings for 1, 2, and 3 hours. The table also lists the information as order pair, hours and earnings. Label the x-axis and y-axis, graph the order pair, describe the pattern in the graph. So before we do it, let's complete our table. As you can tell, the x is hours, the y is dollar earned. So in 1 hour, she earns $5. In 2 hours, she earns $10. In 3 hours, she earns $15. So it's hours, comma, dollars earned. So label the x-axis and y-axis. So the x-axis will be hours. The y-axis will be dollars earned. So I'm going to use different color. So now it says graph the order pair. 1 hour, she earns $5. In 2 hours, she earns $10. In 3 hours, she earns $15. Hey, it creates a line. But we're not going to connect the dot. I just want to show the dots. Describe the pattern. What can you tell me about this? It's a steep line. But one thing I can see is, in an hour, she earns $5. So it seems like every 1 hour, she earns $5. Every 1 hour, she earns $5. So my conclusion is, for every hour, she earns $5. Next year, you're going to talk about slope and all that kind of stuff. So I'll leave that for next year. So for every hour, she earns $5. Or earned for every hour, she earned $5 because you already earned it already. Next one. Here's another table. Here's Kaylee. Kaylee travels on her scooter for 1, 2, 3, and 4 hours. The distance also lists the information as order pair, time and distance. They forgot to label our x's. Don't worry, we can do it. And they forgot to complete our table. Don't worry, we can do it. So label the x-axis and y-axis, graph the order pair, describe the pattern in this graph. So looking at this table, a distance or scooter, time and distance. So x is time, the y will be distance. So in 1 hour, she goes like 4 miles or 4 kilometers, a distance of 4. In 2 hours, she goes a distance of 8. In 3 hours, she goes a distance of 12. In 4 hours, she goes a distance of 16. So let's label our x-axis. Our label axis is time. Let's label our y-axis, distance. So let me use a different pen code. In 1 hour, she goes a distance of 4. In 2 hours, she goes a distance of 8. In 3 hours, she goes a distance of 12. In 4 hours, she goes a distance of 16. So what would 5 hours be? 20. 6 hours would be 24. Ooh, do we see a pattern here? Seems like for every hour, she goes a distance of 4. So it is for every hour she goes a distance of 4. So for example, for 7 hours she goes a distance of 4 for every hour. That'd be 28. For 12 hours, distance of 4, that'd be 48. A distance of 48. And so very soon, in subsequent lessons, we're going to learn how to find the, looking at numbers, a table. Can you tell me the relationship between input and output? Function. But not yet, not yet. Last but not least, 2 friends are each saving money in their bank accounts. Marcus saves $10 each week, while his friend David saves $15 each week. Good for David. Make a table for each friend that shows the total amount saved for 1, 2, 3, and 4 weeks. List the information as order pair. So what is the x-axis and a y-axis? X-axis will be weeks, y-axis will be total saved. Let's go back to this. So weeks and total saved. If you want to, we can go to our graphs and label it. It's weeks is x-axis. Total saved is the y-axis. So we can complete our table. Let's go back. Marcus saves $10 each week. In week 1, he saves $10. So 1 week, $10. In 2 weeks, he saves $20. In 3 weeks, he saves $30. In 4 weeks, he saves $40. So x-axis is weeks, total save is y-axis. Let's use green. Oh, make sure I write down the color because you're going to graph 2 lines on this graph. So, in 1 week, I cannot remember, short-term memory. David saves $15. So in the first week, he saves $15. 1 week saves $15. In 2 weeks, that's another $15, $30. In 3 weeks, another $15, it'll be $45. In 4 weeks, he'll save another $15, it'll be $60. So we need to graph this. Let's start with our first person of Marcus. Marcus saves 1 week, $10. 1 week, $10. So 1 week, $10. 2 weeks, $20. 3 weeks, $30. 4 weeks, $40. It makes a line. So make sure we graph it. Yes, we did. Next one. Let's take our green. In 1 week, he saves $15. In 2 weeks, he saves $30. In 3 weeks, he saves $45. In 4 weeks, he saves $60. So as you can tell by this, it seems like the green dot, who's the green again? David saves more money at a faster rate than his friend Marcus. That's what my name. So, how do the rates of Marcus saving and David saving compare? How is this shown in a graph? From what I can tell, the green dot, which is David saves more money than his friend. He saves it at a faster rate. It's more steeper, the line. So Marcus saves more money than David. He saves it at a faster rate Also, you can say the line is steeper. If you connect the dots, the line would be steeper. It's more straighter. It's more vertical. So, predict the amount for each friend will have saved after 8 weeks. So if I graph Gabe all the way to 8 weeks right here, could we still do it? Well, we know Marcus saves $10 every week. 10, 10, 10, 10. 5 would be 50, 6 would be 60, 7 would be 70, so 8 would be 80. So Marcus will be $80. Or another way to do it is each week he saves $10. 8 weeks times $10 will be $80. His friend saves $15 each week. So $15, 30, 45, 60. Another $15 will be $75 right here. Add another $15 to the 6th week. It'd be $80, $90. Add another $15, it'd be $105. Add another $15, it'll be $120. So his friend David is $120. Or another, each week, for 8 weeks, each week he saves $15. So it's $120. So that's how I was able to find it. Another way you can find it is using your graph. You follow the trend to see what it goes up to. And last but not least, John makes trail mix to take on his hike. For every cup of raisin, he adds 2 cups of mixed nuts. Nuts and raisin. John creates a graph below to represent this ratio. Complete the table. So 1 cup of raisin, he adds 2 nuts. 2 cups of nuts. So he adds another cup of raisins, so he adds another 2 cups of nuts, so that'd be 4. Then he adds another cup of raisins, so he adds another 2 more cups, that'd be 6. And if you want to keep on going, for 4 cups of raisin, he adds another 2 more cups, and that'd be 8. Is this graph correct? Let me think about it. 1 cup of raisin needs 2 cups of nuts. First of all, that's lower than it's supposed to be. That's weird. 2 cups of raisin is 4. Maybe I'm doing it wrong. 3 cups of raisin needs 6 cups of nuts. 4 cups of raisin needs 8 cups. My dot, it would make a linear or a line. This is like a curve. That is so strange. I don't know. I'm doing it right, or maybe I'm doing it wrong. Do the table and graph correctly represent the ratio of raisins to mixed nuts in John's ink? No. If the graph does not represent the ratio of raisins to mixed nuts in John, correctly graph the relationship on the same graph above using a different color. Hey, I did it without even knowing this question. What order pairs did you use to create your table? The graph. I used 1, 2, 2, 4, 3, 6, and 4, 8. For every cup of raisin, you need 2 cups of nuts. So why is it no? Because it needs to be a line, not a curve. If John adds 12 cups of mixed nuts to his trail mix, how many cups of raisins should he add? So let's go back. So if you want to do it, so 5 would be 10. So 12. Would it be 6? I think so. 1, 2, 3, 4, 5, 10, 6, 12. It is. So if he has 12 cups of mixed nuts, you look at your table. If you want to, you look at this one. So many ways to find an answer. 12 cups of mixed nuts, you need 6 cups of raisin. 6 cups of raisin. Very soon we're going to learn all about a ratio table. A function table. So just like if you do input and output, how do you turn a input into an output, or vice versa? It seems like you have to divide by 2, or you double it, times 2. Anyway, so this is graphing a ratio table lesson. So what you do is you're given a table, and then you have to graph the x-axis and the y-axis. you label it, and you graph it. And then you can make all kinds of prediction about your graph.